Welcome to our video summary of how a secret piece of hardware may finally make AR glasses into a computing platform a reality. If you find this content a real-time saver to explore new ideas, please hit the like button and subscribe for more. For over a decade, the dream of smart glasses has been just that. A dream, a tantalizing promise of a future where digital information is seamlessly woven into the world around us. But that dream has been haunted by the ghost of Google Glass, a product so far ahead of its time, it became a punchline. Ever since the industry has been stuck in a frustrating dilemma. On one hand, you have the heavyweight champions of immersion, powerful headsets that can create breathtaking mixed reality worlds. But let's be honest, you're not wearing one of these to a coffee shop. On the other hand, you have sleek, stylish smart glasses that look great, but are little more than phone accessories. We've been forced to choose raw power or practical portability. But what if that choice is a false one? What if the breakthrough we've been waiting for isn't about making glasses smarter, but about rethinking where the smart part even lives? Today, we're looking at Google's quiet comeback, a project that argues the answer isn't in the glasses at all, but in your pocket. Let's break down the core conflict. To create a truly spatial computing experience, you need a ton of processing power, multiple cameras, and a high-resolution display. All of that hardware generates heat, adds weight, and drains a battery fast. The result is devices like the Apple Vision Pro, priced at a staggering $3,500. They weigh around 600 grams, strapped to your head, and are designed for stationary use. They are incredible pieces of technology, but they are not all-day wearables. They're face computers. Then you have the ultra-portables. These glasses are lightweight and socially acceptable, but they offload almost everything to your phone. And their capabilities are a shadow of what true mixed reality can be. So how do you get the power of a headset into a form factor you'd actually wear in public? Google and its partner, XReal, think the answer isn't in the glasses at all. This little device is the unsung hero of Google's new strategy. It's a split compute architecture, which is a fancy way of saying they took all the heavy hot parts out of the glasses and put them in a separate device. It's part of their flagship AR experience, called Project Aura. The concept is deceptively simple, but it solves the biggest problems plaguing AR glasses. Here's how it works. First, the puck is a pocket-sized tethered device that contains the main processor and the battery. By moving these components off your head, you immediately solve the issues of weight and heat. The glasses can be lighter, more comfortable, and avoid cooking your temples. And this is where it gets crazy. This isn't some underpowered mobile chip. The puck is packing the Qualcomm Snapdragon XR2 Plus Gen 2 chipset. If that sounds familiar, it's because it's the very same high-performance chip found inside the full-size Samsung Galaxy XR headset. You're getting the processing power of a dedicated mixed reality headset. But all the heat and heft are offloaded to your pocket, not your face. Plus, the puck's surface doubles as a high-precision trackpad, giving you a physical input method for mouse-like control, solving one of the biggest frustrations with early AR, because the heavy lifting is handled by the puck. The Project Aura glasses themselves can focus on creating a stunning visual experience. But here's the crucial strategic detail. Project Aura isn't just a one-off gadget. It's a reference design meant to showcase what Android XR can do. By offloading the compute, XReal and Google have been able to pack in features that were previously reserved for full-blown headsets. The glasses have a 70-degree field of view, creating a huge, immersive screen. They use optical see-through with Sony Micro OLED displays, layering high-quality digital content directly onto the physical world. They weigh just 80 grams, less than a deck of cards. Using 3 cameras, the glasses have full spatial awareness and hand tracking. This isn't just about numbers. It's about being able to set up a virtual workspace on a plane, play an immersive 3D board game on your kitchen table, or watch a movie on a giant private screen, all with a device that feels more like sunglasses than a headset. But as we all know, incredible hardware is only half the story. This is where Google's master plan comes into focus. They aren't just building a single device. They're building an entire platform called Android XR. Think about what Android did for smartphones. It created an open ecosystem that allowed dozens of manufacturers to build different phones on a common software foundation. Google is doing the same thing for mixed reality, giving developers a massive potential audience from day one. The glasses are also deeply integrated with Google's Gemini AI. The cameras don't just see, they understand. You can look at a lamp, use Circle to search and find out where to buy it, or see real-time translation captions in your view. And this might be Google's checkmate move. They're planning support for iOS, while Apple builds a walled garden. Google is positioning Android XR as the option that still works with your iPhone. So, while these glasses are the star of the show, the real breakthrough, the quiet revolution, is this little puck. By splitting the compute, Google and Xreal have seemingly cracked the code that has stumped the industry for years. They've delivered headset-level power in a form factor that's finally approaching mainstream wearability. So is this the final form of AR? Absolutely not. But it might be the design that finally starts to mend the broken promise I talked about at the beginning of this video. It's a clever, practical bridge that makes high-performance mixed reality accessible today, not in some far-off future. It's a design that could finally bring spatial computing out of the living room and into the real world. But I want to know what you think. Is the split compute design the breakthrough AR has been waiting for, or is the wire a deal breaker? Let us know your thoughts or suggestions for future content in the comments. Thanks for watching. We'll see you in the next one.